Next, we'll discuss the quotient property. You can see here that the quotient property says if you take the square root of a fraction, it's the same thing as taking the square root of the numerator and the denominator and making that new fraction out of them. So the square root of 9/25 is the same thing as the square root of 9 over the square root of 25, which equals 3/5. Before we try some more examples with the quotient property, we'll look at a few more conditions for a radical to be in simplest form. We've already mentioned that the square root of 8 is not in simplest form because it can be broken down into 4 times 2, and 4 is a perfect square. So we would change this into 4 times 2, and 4 is 2 squared. So rather than writing 2 times 2 times 2, we're going to group it into something with a pair so that we can simplify this as the square root of 2 squared times the square root of 2. And because we know that the square root and the square are inverses, we know that that first one's just going to cancel each other out, and the square root of 2 squared equals 2, and then you still have an extra root 2 behind it. So the square root of 8 can be simplified to 2 root 2. Now in the next example, the square root of 5/16. A radical is not simplified if there is a fraction in the radicand. So that's where you'll use our new property where we change this into the square root of the numerator over the square root of the denominator, and we get root 5/4. So in the last example we did both the numerator and the denominator ended up simplifying. This time only the denominator did. And the third thing you need to look for is that a radical is not simplified if there is a radical in the denominator or the bottom of the fraction. So sometimes this will just work out quite nicely. The square root of 4 is 2. Other times you'll have to do some work to eliminate that radical in the bottom of the fraction. So let's try another example here. We're going to simplify the square root of 20/4. And what we'll do here is we'll change this into the prime factorization of 20, which is 2 times 10, and 10 is 2 times 5. And 2 times 2 can be rewritten as 2 squared. And now I can use my product property in the numerator, and I can change this into the square root of 2 squared times the square root of 5. And I know that squaring and square rooting are inverses, so that first radical, the square root of 2 squared, just equals 2. And here's something new. If you have something like this, you have a 2 and a 4 making a fraction, you're going to reduce that just like you always have. 2/4 reduces to 1/2. So you can kind of pull out that numerical part and split this problem into plain numbers like integers versus radicals and simplify the 2/4 part, and then use what you know about fractions to multiply straight across the top and straight across the bottom. And our final answer here would be the square root of 5/2. Now, typically I would not show nearly all those steps, and depending on the way you approach this, you might do things in a different order, and that might change your work, but you will end up with the same solution at the end.